Hey folks, we are starting velocity versus time graphs. We've finished our position versus time graph analysis, and so we're now looking at a different way to represent motion. The velocity versus time graph is probably the type of motion graph you will interact with the most because it relates to a lot of different things. So in this first video, we're going to focus on two things, really just describing the motion of an object using a velocity graph, and then also acceleration. So acceleration is like pretty easy because we have like a template for this. When we were looking at a position versus time graph, we saw that the slope of a line on a position graph is equal to the velocity. And we dealt with average and instantaneous velocity. Because velocity and acceleration are both rates of change, we can apply the same reasoning to acceleration that we did with velocity. So up here I have acceleration, delta v over delta t. That's our definition of acceleration, and acceleration is also the slope of a line on a velocity time graph. So I will leave the calculations up to you to practice. I numbered the axes here. I didn't really need to, but I will leave this calculation to you. What we're going to do is just describe the motion of this object based on its velocity versus time graph. So we'll start with some simple stuff, and then we'll see if anything gets really complicated. So for segment A, the velocity starts at 0, and after 3 seconds, it ends at 2. So we can like do this without numbers. We can say like the velocity becomes more positive. But we can use our definition of acceleration here to say more. We can say, well, the velocity did become more positive, so another aspect of segment A is that it's constant positive acceleration. Now, the reason I can say that it's constant is because acceleration is the slope of a line on this graph, and this line is a straight line. So it has a constant slope, and therefore it has a constant acceleration. The acceleration is positive because the slope of this line is positive. So I can say that as well. Okay, in another video you learned about speeding up and slowing down in terms of acceleration. And so the last thing that we can write is this object is speeding up. Now, knowing that, there's a couple different ways you can know that. The velocity becomes positive, and the acceleration was positive. And when those two vectors have the same sign, then the object is speeding up. But there's an easier way. This line is trending away from 0. So the line is moving away from the x-axis. So that object is speeding up because the magnitude of the velocity is increasing. Cool. So there's a lot of ways to talk about these graphs, and so that's that first segment. Segment B, the velocity is 2 meters per second for 3 more seconds. So this one's a little bit easier. This is constant positive velocity. And so that means the velocity has stayed the same for that time interval. If the velocity hasn't changed, then there has been 0 acceleration. Okay, moving on to segment C. Segment C is one that often gives people trouble at first. So in segment C, we have a velocity that starts at 2, and then after like 2 and maybe 3/4 seconds, the velocity goes down to 0. I'm going to use segment A as a template. So velocity becomes less positive. You can also say more negative. but saying less positive might give you a clue as to what's happening. If I look at this line is a negative slope, and so this is constant negative acceleration. And so, acceleration on this graph is just based on slope, not where the line is. So that's something that you want to try and remember. And the last thing is like speeding up or slowing down. This object is slowing down. You would be tempted maybe to say decelerating. That just means that it's slowing down, doesn't infer what direction it's going in. So that might be useful. Okay, so slowing down. Now let's look at the velocity and the acceleration again. The velocity is decreasing, but that only tells us about the acceleration. This line is above the x-axis, so this line represents only positive velocity. So one of the ways that we know that this object is slowing down is that it has positive velocity, and we've also said it has negative acceleration. When those two vectors have the opposite sign, the object is slowing down. So it's accelerating in the direction opposite its motion. The other one would be that the line is moving toward the x-axis. The magnitude of the velocity is getting smaller, and so it is slowing down. So that's confusing, but A and C are useful examples to think about when you're stuck. Segment D is another one that tends to give people trouble. This little segment here that begins at like 8 3/4 seconds and ends at 10 seconds. Now this one is velocity becomes more negative. And that's easy to see, right? So far, so good. This is a line that has negative slope, so we can also say constant negative acceleration. And so far we haven't said anything really crazy. But what is happening here is like this object is now moving in the opposite direction that it used to be moving in. It had positive velocity for this entire time, and now it has negative velocity. So this object is actually speeding up. Okay. The two reasons we know is the velocity was negative and the acceleration was negative. And more importantly, this line is again moving away from the x-axis, right? So this line is pointed away from the x-axis. So line away from the x-axis. So hopefully that gets you started on velocity versus time graphs. We will pick up with a little bit of like calculations a little bit later in another video. Thanks.